Learning goal number 26, symmetry.
Learning goal number 26, symmetry. We're going to talk about two types of symmetry today. The first type being line symmetry. A figure has line symmetry if it can be folded over a line so that one half of the figure matches the other half. Now, this line of symmetry we use could be vertical, it could be horizontal, it could even be diagonal. If you take a look here at this first figure, it's like a kite, right, where these two pieces up top are the same length and the ones down here are the same length. And I can divide this in half vertically so that when you fold it, you get the same thing on both sides. That wouldn't happen horizontally, right? This top part would not necessarily match the bottom part. But if you take a look at the second figure, that would have a horizontal line of symmetry, not a vertical line of symmetry though. So if I fold that, I would get the same thing top and bottom. Now the next one, I can't draw a vertical line and I can't draw a horizontal line. I don't even think a diagonal line would work. This has no line symmetry. All right, now the first one had one line, it was vertical, and then horizontal, and then no lines, right? Take a look at this figure, this cross figure. You can see that it has a vertical line. If I draw it appropriately, the left and the right side match up. And it has a horizontal line also, top and bottom. But even if I fold it diagonally like that, or like that, I would end up with lines of symmetry also. So that has four lines of symmetry, a vertical, horizontal, and then two diagonal lines. And that is line symmetry. All right, rotational symmetry is the fact that a figure can be rotated between 0 and 360 degrees to match itself. So I've copied each one of these so you can see. This first figure is a square. If I take the second one here, and I'm going to try to rotate it until I get the same thing. I want to see if it has rotational symmetry. And if it does, how many degrees did I have to rotate it? I know that's not perfect, but if that was a square, you know what, it's not a square. We'll say it's a rectangle. So I rotated it 90 degrees there, from here to there, that's 90. And then if I go again, now I get the same thing. Well, what I've done is I've rotated it 180 degrees. So it has rotational symmetry, 180 degree rotation. Now if I take a look at my second figure there, it's a heart. If I go to rotate this, I've gone 90 degrees, 180, 270, 360. Nowhere in between did I have the same figure. So this has no rotational symmetry. Now to track the angles in between, there's 0 degrees, 90, 180, 0, 90, 180, 270, and then 360 would be all the way around. You want to make sure you're looking and seeing where it lines up. And then in between here you got 45, you got 135, you got 225, and you got 315. So those are the most common ones where, hey, I just turned it 45 degrees and I got the same thing. I turned it 90 degrees and I got the same thing. So you want to see if you can rotate it somewhere between 0 and 360, and if so, how many degrees does it take to get the same figure in return? All right, now you're going to try a few problems on your own. You're going to do page 101 in the workbook, and you're going to identify from each figure if it has line symmetry and if it has rotational symmetry. Page 101, here's those 6 problems now.